Hello everyone, welcome back to the Meetup group. It's a wonderful Saturday morning here in Munich. We're going to have a wonderful discussion as we had yesterday about ISO 21434. All right, I'm going to start and talk about today's agenda. Today we're going to talk about basically three things. We're going to do a little bit of Meetup group introduction. We're going to have an overview of ISO 21434, and in the end I'm going to hold a Q&A session. And what I'm going to tell you is if you want to ask question in the Q&A session, we'll do the following protocol. You type Q if you want to ask a question. We'll give you the video and the audio. If you don't want to share your audio and video, then just type the question. I want you to know, because of GDPR, if you ask a question that will be televised in social media and you are giving your consent, okay? All right, I saw some echo, so I stopped. So I want you to know that this is a legal obligation. So I'm moving forward. So our autonomous vehicle safety and security group, now we have this many groups that we have created. We have created a general group. We have created a Munich group where we were actually doing physical meetups. Now, due to COVID-19, we're doing an online format, and the online format has been phenomenal for us. Yeah, we'll continue this format. Even though things will get back to normal, we'll make a hybrid model of online and physical presence. So we have a Stuttgart group, Frankfurt group, North America, Detroit, China, Israel, Japan, India. So if you want to get involved in this group, please get in touch with my colleague. I'm going to give you their email address in a second. So let me talk a little bit about the mission of this meetup. So what we want to do is we're at a dawn of an era where we'll see unprecedented changes in the automotive industry in the coming few years. And I think if we don't do it right, especially in safety and security, we have a problem, because in my experience, I see that technology moves much faster than security. And we have seen incidences in the past that caused a lot of problems in the traditional IT industry that created a lot of losses too. But now we're talking about automotive industry, and if we do not make it secure and safe, we're talking about not financial damages, not privacy damages, we're talking about lives here. So I think this is important to get it right, and that's why a dialogue is very important. That's our mission, and what we want to do is to build a community. So I thank everyone, every participant, to be a part of the community. I really, really appreciate it. And Meetup is one of our way to go with this dialogue. We also do podcast, and our podcast is televised on YouTube and iTunes, Google Podcasts, and every other channel. Can anybody tell me how many of you follow our podcast? Can you say yes in the chat box? Oh, Chitra, thank you. And that's it. Oh, that hurts. So only one person is following, and we really appreciate, Chitra, you following our podcast. So yeah, we do a podcast, and this is where I bring in the industry leaders and expert and talk about current topics. So we encourage you to go and follow the podcast. It's in our YouTube channel, Matrickz TV, and you can find, if you search for Autonomous Vehicle Safety and Security Podcast, you will find Google Podcast, iTunes, Anchor, Spotify, and all those links. So really appreciate it. I'm moving forward. Coming back to the list, so in Munich, we have been doing the physical meetups too. We will do the physical meetups in the future when things get back to normal in other parts of the world too. So I encourage you to get involved and yeah, be with us. So if you want to get involved, here are my two lovely colleagues, Michael and Alex. Please get in touch with them. Here is their email addresses, and they will help you. And yeah, this is how we will go forward. Now, before I even get into the overview, I want to share a personal story. The story is there are certain things that I learned by doing things wrong. And these are the things that I wish I know 2 years ago. And these are the lessons that I'm going to share with you today. When I talk about an overview of ISO 21434, the standard for automotive security, the number one thing that I've seen is people, when they talk about automotive security, they don't talk about necessarily the same thing. It depends on which perspective they're coming from, which angle they're coming from, which part of the company they're working for, what's their job title, what's their role. So it's very important before we even dive into the topic of automotive cybersecurity, we kind of ask the question, what is automotive cybersecurity? And in my opinion, there are four landscapes of four areas in the automotive security landscape. The first one is vehicle network security. Here, what I'm talking about is literally the car when you talk from one ECU to the other, ECU to ECU communication. So that's one. We have to make sure when we send any message via vehicle network, it is secured. But that's not it. We want to send messages from the vehicle to the back end, and that has to be secured too. That's one other part of the landscape, security landscape with automotive security. And what's also very important is the back-end security. That's the infrastructural security itself. Because this is an interesting question that I often get, that how do I know that my back-end is not compromised or not? Because I'm talking to the back-end all the time. It's giving me the access to the keys. There are security protocols that's coming back and forth. And if the back-end is compromised, I have a problem. So that's the third area of the automotive security landscape. And finally, what we're moving toward is the vehicle to X security, when the vehicle will communicate with other vehicles, when the vehicle will communicate with the infrastructure, when the vehicle will communicate with anything that is out there in the environment. So this is where we have to know which part of the landscape we're in. Are we talking about vehicle network security, vehicle to backend security, or backend security itself, or vehicle to X communication? It turns out the second lesson that I've learned is it's not enough. When we talk about automotive security, it's often we're not sure which generation of the vehicles we're talking about. So this is where the second question comes in. What generation of vehicles are we talking about? So this is where the term connected vehicle is very interesting, and it also, like I said, the lesson I've learned, it creates a lot of confusion time to time. And we discuss and we realize that we're talking about different generations. So I try to sit down and try and build a picture where we can have a taxonomy or a clear picture of the generations of the vehicles, connected vehicles. So in my opinion, the first generation of connected vehicles started a long time ago. Remember those times when you didn't really have any connectivity in your car, but you were able to connect your mobile devices with a jack or sometimes Bluetooth or your navigation device, and that's how you were connected. Theoretically, there was a chance that you could have been attacked here in generation 1. Then generation 2 is exactly what we are today. Every vehicle has an IP address, and you're connected to the back end, you're communicating with the back end. Your car has an infotainment system, OBD2 port, you're receiving GPS signals, and so on. This is generation 2 of connected vehicles. Generation 3 of connected vehicles is something that we're heading toward. Vehicle to X communication, where our vehicle will not only be communicating with the back end, it will be communicating with other vehicles. It will be communicating with the infrastructure. It will be communicating with the traffic lights, and so on. So that is the generation we're heading toward. And this is where connectivity will go to, however, the complexity will go beyond it. Although the connectivity will be similar, but autonomous vehicle will take it, the ADAS functionalities and others will take it to a level that will not only be communicating with our environment, we will have tons of data that we will be taking in from our environment and will make decision based on that. So that is going to be much more complex. So it's very important when we talk about automotive security or even a standard like ISO 21434 to really specify which area of the automotive security we're in and what generation of vehicle are you talking about. Now, the scope of ISO SAE 21434 is the first two, the vehicle network security and the vehicle to backend security. It does not talk about the infrastructural backend security. It does not talk about vehicle to X security. It is within these two. I want to make sure that whenever I send a message or something is happening in the vehicle network, it's secured. I want to make sure whenever I'm communicating with the backend, it's secured. Now, it involves ECUs and telematic units and gateways. So that's the scope, and this is where we're going to navigate today. Now let's move on to the building blocks of automotive security. So automotive security, definitely you need a process, and that's why we're developing ISO 21434. The standard is not yet released. We have a draft, and the draft gives us a guideline to how it would look like in the future. Cybersecurity management is very important. From the organizational level, organizational culture, security policy, and how will the life cycle look like, that's why it's very important. Along with processes and the security management in place, you will need security mechanisms, the tools that you will actually implement, you will put in practice for cybersecurity to solve cybersecurity problems. So today, we're going to focus on the process part. In terms of security mechanisms, we have made a lot of advances in the past couple of years, past decade, I would say. We have pretty good intrusion detection systems. We have firewalls. We did a great deal of crypto, HSM. Now we have a standard. These are the tools we have at our disposal. And this is what we're not going to cover today. I'm going to straight away move to security processes. Now, ISO 21434 has much broader scope than the bullet points I've written here. And obviously, within an hour or so, I'm not going to cover the entire standard. I have cherry-picked some of the aspects that I found interesting to discuss with and discuss about, and this is what I'm going to discuss today. So we'll have a look. How does the document look like? What's the structure of the document? What are the contents in there? This is what we're gonna have a look. We're gonna look at the synergies with other standards. That's very important because this is where I see my clients are asking me questions. Look, we have an existing process that's based on ASPICE, or we have an existing process that is based on ISO 26262. This is another new standard. We have to develop a process. How do we do that? So we have to look at the synergies with other standards. In my opinion, where we will need a massive amount of re-engineering is the interfaces in the supply chain. How does the supply chain work? And what are the interfaces? And will our traditional interfaces help? These are the questions that we'll be asking here. Then we definitely are going to look how we define cybersecurity goals and how do we trickle down requirements from them. Another interesting topic. Finally, we'll look at cybersecurity risk assessment. How do we assess risks in cybersecurity? The standard goes beyond these topics. Like I said, I cherry-picked them, but I think these points are very interesting and worth discussing about. Now let's start with the document structure. These are the chapters and the sections of the current version of the draft. Let's have a look at them. Let's zoom in a little bit and have a look. So chapter 5, before chapter 5, it's all glossaries and stuff. Chapter 5 starts with the governance, cybersecurity management, the first aspect, the first building block that I was talking about. And what does that entail? It entails from security governance all the way to information security management, tool management, and everything. I think this part is very important because this is where the policy and the criteria will be defined that this much of security we want to implement in our vehicle, and this much of risk we're willing to take, and this is how we'll manage our entire security life cycle. So that's very important. We're gonna see that when it comes to security, lifecycle management is very, very important because unlike our traditional way of developing in automotive, where we have an SOP where we certify the code and we freeze the code, this is going to be much more different because we will have to keep shipping patches. And I'll come back to this point once we are talking in detail about it. Chapter 6 is about project management. This is similar to your ASPICE or ISO 26262 project management, where you define the roles and the responsibility, you have a plan, you define the activities, you make sure you reuse stuff, and so on. So I could well imagine that this is where your assessor will come and give you an assessment based on some criteria to certify your cybersecurity related product. Chapter 7 is very important. This is exactly what I was talking about when I was talking about organizational culture and organizational policy. And I mentioned that unlike traditional way of developing, this is where things will be different. You will have to continuously monitor security. You'll have to assess the events. You have to analyze the vulnerabilities and so on. So this is where continuous cybersecurity activities will be defined. Finally, the risk management is one of the major chapter in the standard, and I think this is what we're going to talk a little bit in details. We're going to dive deep into this. How do you identify assets? How do you identify the potential damages and the impacts that can be due to a certain threat on certain assets, and so on. This is where you will quantify the risks. And a lot of people were asking about if they can put a probabilistic number on risks or attacks. I understand them that they're coming from functional safety where we work with probability, but there is no probability for attack. Attack is not a probabilistic event. Again, I'm going to come back to this and talk in detail about it. Then comes to the concept phase. This is where you define the concept and cybersecurity goals based on the attacks and the damages, the impacts that you have identified in the previous phase of the development cycle. And you come up with cybersecurity concepts, something similar to your functional safety concept in the concept phase. And then in the product development phase, you trickle down requirements of cybersecurity and design a secured architecture. Then comes the verification and validation part in chapter 11, and which is very important. And in today's talk, I haven't included anything that relates to validation, because validation is a vast part of the standard and security activities itself. I think we will do another meetup, another session where I will only focus on validation. So today, we're not going to talk about validation. And what happens afterwards, post-development? Like I mentioned in the beginning, that post-development is very important. Security activities does not end here. It goes beyond the development phase because of the incidences, because of zero-day exploits, vulnerabilities. We have to ship updates. We have to keep shipping updates and so on. And finally, chapter 14 mentions decommissioning, because like every other product, we gave the example of Windows yesterday, that at one point Microsoft said, hey, we will not be giving any more patches and supports for this version of Windows anymore. Similarly, in automotive, we have to have a decommissioning. We have to say at one point that this is the end of support. The chapter currently says that is out of scope, and this chapter is pretty much empty. So the standard does not cover decommissioning. Finally, in chapter 15, we talk about distributed cybersecurity activities. What does that mean? It means in the automotive supply chain, we have many suppliers, tier 1, tier 2, and so on. It is very important to have a commonly defined interface. So how do you evaluate the supplier capability and so on? How do you request for a quotation? How do you align responsibilities? This is similar to your DIA that you do in ISO 26262. So that is pretty much the structure. Now we're moving to this is another way to look at the structure. This is where the entire V is covered. So you start from cybersecurity goals all the way down to architectural design, and the right-hand side, you do the validation in terms of security. Now, today we're going to stay on the left-hand side of the V model. We have talked about the first bullet point till now. We have seen the document structure, document overview. Now let's move on to the second bullet point that we wanted to talk about, which is synergies with other standards. This is, again, very important. This is the pain point most of my clients have today. These are the things they're worried about, and I'm going to give you my insight to that. Let's look at what the standard is mentioning about this. So the standard, the beauty of this standard is this standard has taken a lot of input from the existing standards. For example, it has taken inputs from ISO 26262, the standard that has been there for automotive functional safety for a long time. It has taken input from ISO 31000, the risk management, cybersecurity risk management standard. That has been there also for a long time. And it has taken also input from IEC 61508, the standard for electronic systems. And we had this guideline, SAE J3061, for a long time at our disposal. And the standard supersedes the SAE J3061. So the standard is beautifully designed to be compliant with ISO 26262, which you know that it beautifully harmonizes with ASPICE. So here is my thought. The customers, the clients who are saying that, yeah, it's a new standard, we don't know how to deal with it, how we have our existing standard, and we do a gap analysis for them. When we do a gap analysis for them, most of the cases what we find out that the gap is not in ISO 21434, the gap is in their existing standard. The gap is in ASPICE. So my bet is if you have a nice, solid, working, which reflects the reality, ASPICE process and ISO 26262 that you practice in a good way, incorporating ISO 21434 should be not much of a hurdle. Of course, there will be issues, like there's this gentleman who mentioned this question yesterday, when safety and security goals are somewhat contradictory. It will happen. However, if you have the existing base, a solid base, as you can see, the standard should be harmonizable without major hurdle. After that, it brings us to the third bullet point that we want to talk about today, the supply chain. So that is very interesting and that's very important in automotive because the supply chain is vast. Unlike many other industry, automotive supply chain is complex. So when it comes to OEM, this is where they make the final car. Tier 1s, they supply us the system. Tier 2s give us the subsystem, and Tier 3 supplies us the individual parts. If you talk about OEM Tier 1, Tier 2, Tier 3, behind one vehicle, it is estimated to have about 3,000 companies in involvement. Well, that's a massive number for a product. One product to be shipped to the customers requires 3,000 companies' involvement. That's massive. And that's why it's very important to have clear interface in the supply chain. Now, this is again a good news. We are used to this. This is nothing new. We do have these interfaces defined in terms of ASPICE and also ISO 26262. So we have to kind of re-engineer such interfaces for automotive security. There are certain parts that are tricky, but certain parts are also straightforward. So we need to have a cybersecurity interface agreement for development. It is the parallel of the DIA between the OEM and Tier 1. We have to have the same cybersecurity interface agreement between Tier 1 and Tier 2 and so on. Now, the difference here is, the challenging part in this diagram is not to draft an interface agreement, but to contextualize it with certain aspects of cybersecurity. The question of liability, the question of lifecycle management comes in here, because cybersecurity is something that will go beyond the shipment of the vehicle. 5 or 10 years later, there will be vulnerabilities discovered. Now, OEMs will have to have their incidents management because this is where the end consumer will come to the OEMs first and then get their help from there. Now, some of the problems will also go to the tier 1s and tier 2s, and how to define that is going to be the challenge here. This is something that's going to be a bit newer to the automotive industry, and we'll have to have a clever engineering of such interface document. So that brings us to the fourth point that we want to talk about today: cybersecurity goals to requirements. So we have cybersecurity goals defined. How are we going to define cybersecurity goals, and how do we trickle requirements? How do we extract requirements, derive requirements from cybersecurity goals? And what should it represent? As you can see in this picture, it's very similar to the traditional way of defining items. And yesterday we had a question that if the items for cybersecurity and safety should be the same or not. And in my opinion, yes, it should be the same, the definitions of cybersecurity and safety, because items are the group of systems or components, and why should they be different for cybersecurity and safety? And the cybersecurity goals will correspond how do we want to, what kind of security goals do we have here? What do we want to protect the items for? And from that, we will derive the cybersecurity requirements. And in the product development phase, we will have our refined cybersecurity requirements that we will incorporate in our architectural design. At a high level, very straightforward. Let's dive in details. I think this is a redundant slide because this is where I'm going to continue about deriving the goals as well. So in order to derive the goals, we have to have some definitions in our head very clear. So like I said in the beginning, knowing the terms and the definitions very clearly, what exactly we're talking about, what generation of vehicle, what is the landscape, what is the part of the cybersecurity landscape we're in, is important. Equally, the terms that has been used in the standard to have a clear definition is very important. So one thing that you will have to deal with when you will be designing cybersecurity goals is assets. So how do you define asset? Asset is something that you want to protect. It has an intrinsic value to you or to your attacker, anything you want to protect. This is a very commonly used term in cybersecurity, and thanks to the standard, they have actually incorporated this term, and we want to protect the assets. And the assets will relate to your items. This will be part of your items. And each assets will have certain cybersecurity properties. The basic cybersecurity properties are, so to say, the so-called CIA of cybersecurity: confidentiality, integrity, and availability. Let's take an example here. Imagine that we're dealing with a powertrain ECU. And in this powertrain ECU, you have CAN network, and you want to send messages via CAN to the powertrain ECU, a simple task. Now, what is your asset? One of your assets could be the message you're sending to the powertrain ECU. Now, what are the cybersecurity properties this message can have? Is confidentiality important here? Do you really want to make the message that you're sending to your powertrain ECU confidential? In my opinion, it's not necessary. However, integrity is vital. I want to make sure that whatever I'm sending is not being tempered and my powertrain ECU gets the exact message, because if that gets tempered, the speed of the vehicle can be uncontrolled. So integrity is absolutely vital cybersecurity property for this particular asset. What about availability? Yes, we want to make sure that it has very high availability and almost close to 100%. We always talk when it comes to availability, we talk about how many nines. 6, 7, 8 nines we talk about. So we need high availability, and these are the two cybersecurity properties that are really vital for such messages. Moving on. Once you have defined the assets, it's very important for you to also define what kind of damage can occur if something happens to this particular asset, and what kind of threat can cause this kind of damages, or what kind of consequences are likely. And you come up with a damage scenario and threat scenario relationship. That's the second thing you want to do. So cybersecurity in automotive can have four kinds of impacts. One is financial impact. Somebody can steal your car. Or if you have credit card related information in your car, any kind of information that can cause financial damage, they can steal that. So people can cause you financial damage. That's number one. Number two is privacy. They can steal your data. Due to GDPR, that is another topic worth discussing in a separate session. The third impact is the safety impact, which is, in my opinion, the most important one. And safety impact can be due to cyber attacks. And that kind of damage has to be taken in serious consideration. Finally, you can have operational damage. Somebody can cripple your car. So based on that kind of a damage, you'll also have to categorize, and you have to see what kind of threat can cause what kind of damages. Here is a fantastic diagram that is taken directly from the standard, where from goal setting, cybersecurity goal definition, all the way to requirements and defining the threat scenario is illustrated. So I'm gonna start looking at this diagram first from the left-hand side, from the item. So this is where you have your item, which will consist of several components. And your item will be relating to an asset, assets that we talked about. There will be several assets. These assets, based on the threat, now go to the right side of this diagram. Based on the threats and the damage scenario, will have certain security goals, because these are the threats that we want to protect the assets from, and this can cause certain damages, and the cybersecurity goal will be there to mitigate these damages. And of course, these assets will have cybersecurity properties that will be damaged or compromised by the damage scenarios. In order to realize the cybersecurity goals, you'll write the cybersecurity requirements, and you allocate them to the components and to the item itself. So this is where the whole idea of from goal definition to threat analysis is illustrated. Here is another way of looking at the risks. You know, people want to see numbers. Numbers are important when you do risk analysis and stuff. And we're used to the ASIL levels from our safety experiences. So one gentleman asked me this question yesterday, that CAL level, the cybersecurity assurance level, which is a parallel of the ASIL levels that we have in ISO 26262, is this gonna be mandatory? Because the standard puts the definition and everything about CAL level in an annex, but refers to this annex in the actual part of the standard quite a few times. So we don't know if this is going to be a part of the standard or an informative part. We don't know. In my opinion, it's absolutely necessary, because this is necessary not only for convenience, this is also necessary for the supply chain management. This is also necessary for, not every cybersecurity level will be equal, and we'll need different measures for that. Let's have a look at this table and try and understand what this CAL level is about. So like I said, CAL stands for Cybersecurity Assurance Level, and this is nothing new in cybersecurity. We have this kind of levels of security assurance defined in other domains, and here we're talking about 4 different levels. Based on the impacts and based on the attack vectors, you can define your cybersecurity assurance level. Again, there was a question yesterday, is this enough? In my opinion, no, it's not enough. We need to also consider the attack feasibility. We need to consider the skill level of the attacker. Can it be a script kiddie, or does the attacker need to have the knowledge level of a nation state? How is the computation cost of the attack, and so on. So this is a first nice guideline, a directional guideline to go toward the CAL level. In my opinion, it's very important. However, it's not very clear if this will be mandated or not. So here, to sum it up, what I've just said in the entire talk, you start with conceptualizing and then product development. In the concept phase, you do your cybersecurity goal definition. In product development, you define the requirements, do an architecture, and go for production, operation, and maintenance. What's interesting here is this loop of a risk assessment. This should be a continuous and iterative process. At each stage, you do a risk assessment. You identify, analyze, and evaluate risk in each phases of the development, and that is crucial till the end of support. Because cybersecurity is a living process, unlike our traditional way of development. That's why this loop here is very, very crucial, and that's what makes it a little bit different than our way of traditionally developing components in automotive industry. So here are some scopes, and I talked about the scopes already. I'm going to talk a little bit about the limitations. It does not prescribe any solution, which in my opinion, a standard should not. So it's not quite a limitation, but it's not within the scope. So it does not prescribe any solution. You are free to choose whatever solution you want to implement. Then it does not talk about autonomous vehicle. It also does not talk about, how things are gonna be after you ship it in the market and so on. These are the limitations. And I think the draft is in a very, very early version. It's too early to say if this will be the case when it's released or not. But however, I think that it will not include anything that relates to autonomous vehicle, ADAS, because the way of testing in ADAS domain and autonomous domain will not be requirement-based, will be requirement-based, but requirement-based will not be enough. We'll have to go to the scenario-based testing, and I think traditional cybersecurity is requirement-based, so that could be the limitation that will be coming up with. I'm going to point you toward some additional resources. Here is one white paper that you can download and have a look. Another thing that I'm going to talk a little bit about is we have designed an online training for ISO 21434, and allow me to talk a little bit about it. This is going to be helpful for many people too. So the objective was that we were not able to find people. There were really, really huge lack of security people in the industry, and statistically, we've seen that there are like 3.5 million unfulfilled jobs worldwide by 2021. In Europe in 2019, there were like 291,000 cybersecurity experts that was unfulfilled. We couldn't find them. And it's just going to go more. So I'm talking about the entire cybersecurity industry here. McKinsey also published a very interesting white paper where they talk about automotive security is a $4.9 billion industry today, and it's going to be $8.4 billion in 2025, $9.7 billion in 2030. And process-related market value, market share of this today, $3.1 billion by 2025 and $2.4 billion by 2030. So that kind of reminds me when ISO 26262 came out, we couldn't find experts. So this was new. I mean, even 5 years ago, it was so hard to find experts. Now it's much better. As you know, in the current situation, we are preparing for our clients. We do anticipate a peak in demand when the standard will be released. And where do we find these people? This is kind of like a selfish thing to think about when we designed this training. And the best way is to take people and train them. And that was the background of the training. And another point that I want to mention is traditional security experts are not always the fit for automotive security, because automotive is a totally different beast altogether in itself. We found it effective when we train automotive experts with a very, very customly designed security training for them that works. And this is where we thought about, we'll design this training, and thought, okay, we're also going to put it for externals. However, this training will be application only. So this is where I actually wanted to add another anecdote. If you guys have read this book from Malcolm Gladwell, Outliers, where he talked about the ultra successful people around the world. He talks about, he interviewed and researched from Bill Gates to Beatles, all ultra successful lawyers in Wall Street and all that kind of people. Malcolm Gladwell talks about very many variables in their success. One of them was timing. And that's why I think today, in 2020, this training, this ISO 21424, could be a big deal, can make a big difference in a lot of people's career. So that's another point I wanted to make. So the training is application only. We'll be only vetting applicants that we think we can help. And the reason we wanted to make it application only because we didn't want to come up with a training that anybody can sign up. It's like you're selling the videos. That's what we don't want to do. We want to know who are the people who are attending, what is their objectives, and how can we help them. We have been a training partner for many OEMs and German tier ones, for some of them even globally. And we have done it in a classroom basis. We've been very successful. We've been able to help them. We just didn't want to lose this way of connecting and building a relationship with our trainees when it goes to the online mode. That's why we'll be taking only application only. We will be launching this training next month. And this month, the application is open, and whoever will be doing the pre-launch application for the basic training will get a massive discount for being an early participant. And it goes beyond training. We will also provide coaching that will go, one-to-one sessions, and we will be trying to solve your specific company problems. And all these, even the training will consist of monthly Q&A with us, 2 Q&A sessions. And finally, we also have a mentoring program that we traditionally have been doing with our clients on a person-to-person basis. And this will also be included if you want to go for mentoring, where we will talk about your projects, your problems, and try and give you a guideline. So that's what I wanted to talk about. If you're interested, please apply. If you have questions, we have these 2 wonderful colleagues, Michael and Alex. Please get in touch with them. They'll help you as much as help you need. Hope you will be a part of it. With that, I think it's good time to start the Q&A. So if you want to ask question and if you want to have the floor, the mic, please type in Q. And as you know, your question, your video, your voice will be televised in social media, and with typing Q, you're giving us a consent for doing that. I'm obliged to tell you this because of GDPR. And if you don't want your video or voice to be televised, then please type the question. So the first question was from Avishek. Avishek, yes. Can you give the floor to Avishek? And Avishek, can you ask your question?
Okay, I have a question as well.
Yes.
Does the standard talk about breaching of machine learning algorithms?
Very good question. Can you tell a little bit about yourself first? Where are you from? What do you do?
Okay, I'm Abhishek, and I basically work as an automotive consultant currently for Alton. Yeah, I work for one of the Tier 1 suppliers currently, for Magna.
And where are you located?
I'm located in Frankfurt at the moment.
Located in Frankfurt. Fascinating. Thank you for your question, Abhishek. So your question, if I understood it right, is that if they talk about machine learning algorithm.
Yeah, exactly. The breaching especially.
Yeah, they don't. It's like I said, the standard does not go into any kind of prescription. It gives you a guideline for risk assessment, and they tell you the kind of a test that will be necessary to mitigate or check the mitigation method of those risks. The standard would say, okay, go ahead and identify the risks, and they have a methodology for that. And once you identify the risks, there are some tests they recommend in order to cover them. However, when it comes to machine learning in the ADAS domain, I think the standard is even limited here because the standard talks about requirement-based testing most of the time. It does not talk about scenario-based testing, and I don't think that you can robustly test an ADAS system or a machine learning-based system without scenario-based testing. So that for that, I would point you toward SOTIF.
Okay, SOTIF does talk about that, is it?
SOTIF covers scenario-based testing. All right. Do you have any other question today?
Yeah, not at the moment. Yeah, thank you.
Perfect. So with that, I'm going to go to a question.
Will there be a need to normalize safety and security requirements at every abstraction layer? Because sometimes safety and security requirements can be at odds.
Yes, absolutely. This is a very good question. Now I understand your question. Yes, there will be friction between safety and security time to time. There's no question about it. We already have identified some of those. One classic area is timing. In the timing domain, you want to, for safety reasons, you have certain times, task that needs to be executed within millisecond, even microseconds. Now, if you want to make it more secured, you have to add crypto, and that costs computation time. Now, this is a classic example. There are more than that. And yes, I 100% agree with you. There has to be an interface between the safety and security people, and they have to give input to each other in an iterative fashion. That means whenever you do a security analysis and a safety analysis, they will have impacts on each other. So you will have to communicate and talk about those impacts, and then take another iteration till you are not at odds with each other in your language. So thanks for the question. That was a very, very important one. Okay, we have got a question here.
How long is the product supported for security updates according to ISO SAE 21434?
Yes, this is a very good question. This will depend on your decommissioning policy, which this is the chapter that's empty in the current version of the standard. And if this standard will support it or not is a question that I cannot answer. Most probably they will not prescribe any decommissioning time. It will depend on the policy of the OEM. So to give you an idea, when Microsoft ships Windows, there is a certain time period they keep sending patches for a certain version of Windows. At one point they say, okay, from this time onward, we're not going to ship any more patches. So if this vehicle goes to the junkyard or not, that will depend on the policy of the OEM. Yeah. So you have in your last line, you have rightly identified that would be the idea. Okay, Daniel, do you want to type your question, or he already did? Yes, he already did. Okay, so I will see if I can read your question. Microsoft gives an ISO. So Daniel has a very interesting question. So his question is, Microsoft gives an ISO image, which you can use, you can use the OS offline under your risk. What happens today with a Tesla Roadster from 2009 or a Porsche Taycan in 10 years or more? That is a very interesting question. So I think that is similar to the first question that was asked, that what will be the end of support, decommissioning. So the OEMs will have to have a decommissioning policy of their own. And Tesla, in this case, will have their own decommissioning policy, like Microsoft have their decommissioning policy, which you have simply mentioned, that this is their decommissioning policy, that you can actually use it in your own risk. If Tesla will say such things or not, we'll have to wait and see. However, we need to have a decommissioning policy, because it's not realistic to say that you will be providing the patches and the updates forever. Now today, the average lifespan of a vehicle is 18 years. 18 years is a long time. That is simply not comparable to any of the IT domain, like cell phones. Typical lifespan is 3 years. So that's just not possible comparing. For that, we have more stringent development policy. When it's a cell phone, you're talking about data, financial losses and all those. But when it's a vehicle, you're talking about people's life. So there can be differences in the policy. The policy has to be different than the IT domain. The decommissioning cannot be very short. So we need to have a different way of decommissioning. And how will that be? We'll have to wait and see. However, it's very important to have the patches and everything in alignment so that we don't end up damaging people's life. Okay, Michelle, who's next?
Hi, this is Chitra. I work in California with Argo AI in product security. My question is, you talked about cyber assurance levels with attack vector. Is there also alternative mechanism in terms of exposure or attack probability?
Chitra, this is a very good question. I 100% agree with you. The table I showed you, it's actually a screenshot from a table that is given in the annex of the standard. So I think this cal level in its actuality will not be that straightforward. As you know from ISO 26262, when you do a HARA, when you do a hazard and risk analysis, you spend months after months coming up with data, coming up with probabilities and so on. The problem here is that when it comes to safety, you can put a probability, but an attack probability you cannot put statistically. You definitely have to put a number. However, it's not a probabilistic thing. This is really the challenge. I mean, one of the dimensions is sort of like an exposure, whether you need physical access or remote access and so on. One of the dimensions is like that. The other dimension talks about severity. I think there are more dimensions needed here. For example, the knowledge level of the attacker. If something can be done by a script kiddie, that will have one kind of cal level, and if something that then requires nation state level knowledge, that will have different kind of cal level. And what you mentioned also, the exposure and everything, that should play a role. Do you have any comments, questions?
No, I agree with you. Probability is more of a subjective value, not very objective, based on the thumb rule of what we think the system is handling and not handling. We can subjectively score a probability, maybe low, medium, high kind of probability, but it wouldn't be objective.
Yeah, right. It's hard to put a probability. I mean, if you can put a probability on a failure of a hardware based on statistics, but attack is really hard. All right. Thank you very much. Then, Michelle, what's the next question? Yes.
Hello, I'm Patil Devendra. So, am I audible now?
Hello, Patil. So tell me where you're from, a little bit about you, your background, and your question.
Yeah, so I'm Patil. So I'm working in SAE Automotive. So currently I'm based out of Sweden. So for one technical discussion, I came here for our customer, Volvo. So my question is here, I think it is somewhat similar to the previous question. Is there the standard talks about the attack timing, similar to the fit rate, how we talk about in ISO 262?
No, it doesn't. It doesn't talk about attack timing. Can you tell me a little more? What exactly do you mean by attack timing?
Attack timing, probability is basically how to calculate based upon how long the attack can withstand in my a particular system or the component. So based upon that, I can design my system. What will be the response time for that attack and all these probabilities. Can this standard talks about that, or it should be based upon the components and their response timings and more of a physical layer topic?
The standard doesn't talk about that. It is unlike failure. Attack is something where it's really, really hard to put a probability. It's not a probabilistic event because you can put a probability on random hardware failure, but an attack probability, it's hard to measure. It's not easy. Yeah, that's the problem.
So the thing why I asked this question is, so based upon this, I think it will be similar to the ISO 262, so that we can architect our cybersecurity architect level I'm talking, so that we can design our hardware response timings and all. Probably we can make our hardware more security framework, so that it should be response time should be. I'm mainly concentrating more on towards my response.
Yes.
About my system towards that attack, so that I can do probability based upon the attack timing, right? Or system can respond to it.
It's very good point. What you're doing is you are focusing on the safety consequence of the attack. So once your attack causes some safety problem, then the attack probability doesn't matter to you anymore. Then it's an attack. It's like, for example, if someone changes the value of your CAN message in a powertrain ECU, how the attack is coming and how long the attacker can do this is irrelevant. This is a failure to you. How that failure happened from a safety perspective, this is a failure. How that failure happened, is it coming from an attack or not? It shouldn't matter. The rest of the maths is similar to your ISO 26262.
Okay.
You should just simply treat it as a malfunctioning. Of course, it's due to an attack, but that's too late for you to think about the attack. The attack already happened.
Mm-hmm.
Yeah.
Okay. Thank you.
Thank you, Patil. Go to the next question. Yes, Praveen. Why don't you tell us a little bit about yourself and ask your question? I mean, I know you, but for our audience.
Hi, Hasan. So my name is Praveen Suvarna. I'm also currently working at Matrickz. My question was about evaluating the attack feasibility. Whenever we talk about the threat scenario, normally we have to make a conclusion whether the attack feasibility is low or high. So what are some of the important factors we might be considering in coming to a conclusion, whether the attack feasibility is high or low?
Very good question. Feasibility is the right word, not probability. For attack feasibility, you have to think about several things. First of all, the cost of the attack. If the attack is a low-cost attack, it's more feasible. If the attack cost is high, it's less feasible. Then you have to think about the skill level of the attacker, the knowledge level of the attacker. We should differentiate between knowledge and skill. When I say skill, that means how much of a skilled attacker he is, what kind of is he a script kiddie, or do you need nation state, or what do you need? The knowledge level or skill level of the attacker. And then by knowledge, one should also talk about how much knowledge does the attacker need of my system. This is what also the attacker you should consider in order to compute or assess the feasibility. Another thing you should definitely keep in mind is the requirement of accessibility. Is it possible to access and perform this attack remotely? Does the attacker need to be in physical proximity? Does the attacker need to have physical access to my vehicle? Does the attacker need to have access to the OBD2 port? And certain things. So these are the things that you will need to analyze in order to come up with an assessment of feasibility.
Okay.
Thank you, Praveen. Do you have any other question?
No further question from my side. Thank you.
Thanks. Oh, we have a question from Akhil.
Hi, this is Akhil. I work for JLR in the UK. I have a question regarding teleoperation systems where we are driving the vehicle remotely. And my main question is, are the control center and server covered by the standard or not?
Thank you, Akhil. Thank you so much for your question. So your question is control center. What do you mean by control center and the server? Do you mean the back end?
Not exactly. So basically, the vehicle is driven from a control center which might be miles away from the actual vehicle, which can be a shuttle. Yeah. So the operator is communicating to the vehicle through a server or through a mobile network. So the software that is at the control center side, not only software, the whole system, is that also covered by this standard?
You're talking about an autonomous vehicle scenario. Is that right?
Sure, because there is still a driver in the loop.
The driver in the loop, but the driver is kind of like a phantom driver. He's not present.
Yeah, I mean, he's driving remotely. Just the distance is, he's not in the car, but the car is still controlled by someone.
Got it. Such scenario is not included in the standard. So to say that this is out of scope is also not the right thing. The standard practically talks about the vehicle network security and your security with the vehicle and its backend. Even the connected vehicle is a little bit out, far away from the standard. And the scenario that you have mentioned, that you're remotely controlling the car, such scenario is not in the standard now.
Is it applicable to the vehicles which are like also not like, the normal cars, like the small rovers that can be used to deliver food or medicine?
Okay.
I think I have the answer for this, because in this situation as well, they are being driven remotely. They're not being or automatically. So they are L4, L5, and I think the standard, as you said, is not applied to them.
Yeah. And the standard is also for road vehicles. When you talk about road vehicles, you have to kind of narrow things down. It's not the vehicles you will be using in the agricultural scenario, or even maybe the scenarios you have mentioned, whether they will be categorized as road vehicle or not. This is what we have to see.
I hope there is no limitation like 3.5 tons that we used to have in Functional Safety 2011 standard. Or we have something separate for truck and buses over here?
This is a very good question. So truck and bus is a road vehicle. ISO 26262 included it. If in this standard this is included or not, I would tend to say yes. However, this is a very good question. Yeah.
Okay. I think that's it from my side. Thank you.
Thank you.
Yeah, hi. Patil again here.
Hi, Patil. Yeah.
Does this standard talks about different cybersecurity mechanisms, different in the sense like which will be for software side and which will be for like similar to the ISO 262, how we are segregating for functional safety mechanisms for software side and hardware side to protect basically communications and these aspects?
It does not prescribe any mechanisms.
Oh, yeah.
Yeah, what it tells you, it gives you a risk analysis platform. You analyze your risk and mitigate it. The mitigation measure, like the mechanisms, you will choose them, and then it provides validation prescription in a sense that depending on different cal level, what are the validations you have to do, verifications you have to do. That are the things that is prescribed by the standard, but you are free to choose whatever you want to choose.
Okay, yeah. Thank you.
You're welcome. Yeah, we come back to OS if you can hear us.
Yes, I can hear you. Now I can hear you back.
Amazing. Yeah, please tell me your question again.
The question was, I think the CAL is at the moment, it is and not an obligatory or not a required part, but it is actually only optional or informative. Do you think that this will change in the future releases, or will it always stay as it is, as an informative part?
I like this question. So this has been a discussion for a while, if this is going to be only informative or if it is going to be a part of the standard or not. I think, this is my personal opinion, it should be part of the standard. And like you heard in the question when Chitra asked that this is not the way they have defined also as an informative part, it's not a complete way of measuring the cal levels. We definitely, this is my opinion again, we need categorization. And cal is the right way to do categorization. We have it in other domains, and I think it should be a part of it. Whether the standard will make it a part of it or not, that's just, we'll have to wait and see. By the way, can you tell us where you're from and a little bit about your background, because this is the part I missed?
Yeah, I'm from Stuttgart, actually, in Germany, and I was actually in the IT domain a little bit, like from the 27,000, but now I'm trying to switching to the automotive a little bit. This is my area and my background.
Amazing, thank you. Do you have any other questions?
Not at the moment, thank you. Thank you.
Thank you very much.
Yeah, hi. This is an extension to what you told me earlier. So do you recommend any other standards for non-road vehicles like agricultural equipments, lift trucks that we can consider if we can't use this standard?
Do you mean for security or any other purpose?
Securities.
I'm not aware of any. I don't see there is any standard for such things. I'm not aware of. Yeah, that's the only standard we have for road vehicles. However, I don't see why the principles will not be applicable there, some of the principles, but this is really not meant for off-road vehicles.
I was about to say that too. This is Chitra. So the standard is pretty generic for anything with the wheels here, wheels and a compute node, road vehicles. So it should be applicable to agricultural vehicles, provided the damage scenario for the threats you evaluate seems to be reasonable.
I agree. The idea is this will be a different kind of risk that you're talking about. When you're in the Autobahn, German Autobahn, in the fourth lane for the same kind of damage scenario, attack scenario, the risks are way higher when you're in the Autobahn versus when you're actually in an agricultural field. So I don't see why you can't apply it. Yeah, I agree with that.
Yes, I agree as well. Thank you.
Thanks.
Hello, Hasan.
Yes.
Chitra here from Continental Automotive India.
Hello, Chitra. Welcome back.
I have a question. At the concept level, for the same functionality or function of the item or system you can consider, can the item definition be same for both safety and security implementation?
Yes, I don't see why not. I think they have to be the same.
Yeah, but in case of system boundary, I think it may vary for safety and security aspects. If you think in that perspective, if you think of system boundary, security may have more boundary if you consider for any system, but safety will have another boundary.
Right, but it is the same item you're talking about. You can definitely define different boundaries, but there is no reason to defining the items in a different way for safety and security. End of the day, it will be the same vehicle. There was a question during when I was talking, we're giving the presentation, that the odds between safety and security, right? So they'll have to play hand in hand, and we're talking about the same items here.
Okay, thank you.
You're welcome.
Hi, it's Puneet here. So I have one question, if I can go ahead.
Hi, Puneet. Welcome. Can you please tell a little bit about yourself, your background, and then ask your question?
Definitely. My name is Puneet Madan. I'm working in automotive since 15 years now. I am also cybersecurity and functional safety certified, not for this standard which is coming, but for IEC 62443 in this case. One issue which I usually see is that we have very less information about the cybersecurity reports which are coming from different other domains. One of the biggest domain which I want to mention here is telecommunication. Majority of the T-box in today's world are still using GSM-based format, which has an optional certification for encryption, which is also broken anyway. The question is there a reference available or cross-industry activities which is happening so leverage can be given to automotive in this case in bringing this standard up to date?
Great question, Puneet. Can you please tell us where are you located and which company do you work for?
I'm located in Nuremberg. So I'm basically right now changing my company. So I was working till now for a Chinese connectivity provider. Next month, I'll be joining with the new company.
Fascinating. Fascinating. Thank you. I like your question. So the question is, we do not have much idea about, for example, telecom industry in terms of cybersecurity, and if there is any way to have a cross-industry report. I'm not aware of any publicly available report of such type. However, there are companies, telecom companies, who have their specialized department, or in some cases, their subsidiaries working toward automotive. We work with some of them, and they internally do have such data. So what specific domain of automotive are you in? Where do you think where is your pain point right now? Where is the interface? Because if you're talking about future connectivity, GSM is going to be outdated, right?
So if you see the GSM standard, it specifically says that when the load on a mobile cell is higher, then they have a right to deactivate the encryption between the receiver and the sending tower. Now comes the pain point. Now we are moving towards new mobility in which the cars will be deployed in small cities with electric mobility providers. If this is broken, then in this case, your T-box will become really the point which can be hacked. You will get false report and the car will be stolen, and there will be a false server which will be reporting that car is available on location X. I did this study for my IEC 62443 certification. And I find out currently all these small providers are using raw GSM, including the car, because during Christmas market in Nuremberg, which is one of the biggest, I was able to get all the data using simple AI. So that's the pain point for me, and I think that's also one of the biggest risk in this new mobility concept, which a majority of the car companies are also following right now.
Yeah, that's a very good question, and thank you so much for. I mean, you really set the premise really well. This scenario is fascinating. This unencrypted data. If you look at automotive industry, and if you look at traditionally what's been happening, we do not even have. If you talk about the vehicle network itself, CAN does not even have a security mechanism, and there are millions of vehicles in the street where you can simply plug in a device with OBD2 port and sniff the CAN messages and read everything, or even feed the CAN message with false message, because there is no encryption, massively no encryption that was happening in automotive industry for a long time. The scenario that you have mentioned, that it happens in the GSM industry, really amazes me, because that is an industry that's supposed to be much well secured. And this will not only have an impact on automotive industry. I totally agree with you, the point that you've mentioned. Automotive industry will be one of the targets. It will also have GDPR impact. So this is where I think it's the problem that has to be solved in a cross industry level. I agree with you. Unfortunately, historically, what we have seen is this kind of problem are not even addressed unless we get a real hit. Even for ISO 26262, there had to be a huge recall and huge incidents before things were really formalized and put in practice. We know that theoretically it's possible to hack into millions of cars that's out there in the street with the mechanism you mentioned. Of course, also with other simpler mechanisms, but it's not happening because so to say, the internet criminal industry is paying attention somewhere else. But it's just a question of time it will happen. Unfortunately, never in the history that we have seen that industry does something to spend more money on safety or security unless they have to, unless it's mandated by the legislators. The problem in automotive industry is the legislators are not technically in the state to have a comprehensive idea about what to put in the legislation. Take, for example, the autonomous vehicle industry. There's some data from Toyota and from some other companies. We need 8 to 10 trillion miles of data in order to really assess this safety of autonomous vehicle, and then we can come up with some legislations. Now, this is a daunting task. It's just not possible, and it's not only the number of miles that will matter. It's also the test vector. What do you test? Our office is located in Unterschleißheim. We see this nice BMW autonomous vehicles that are running around in Unterschleißheim. That's one thing. You're testing in Unterschleißheim. This is beautiful. But these are the benign scenarios they're testing. How about the malicious or more risky scenarios? And that's really hard to test. And this is also not ethical to test when someone is sitting in the vehicle or putting other people's life in danger. So we have a real big question there. And the problem is legislators do not have anything to point toward. They sometimes do not also see the risks because it's difficult. If we look back in history, when Cambridge Analytica happened, it was nothing new for the research community, for the experts. If you look at the research papers that was published 15 years ago when Facebook came out, we talked about such risks. Nobody needed to be a Nostradamus to predict that this thing is going to happen, but nobody took any of those papers seriously until it happened. So that is where I see this. Your question is a very good question. I don't think there is a technical solution for this. This is a policy problem and a legislation problem, and that has to be solved at that level. Do you have any remark, follow-up, or any follow-up question to that?
No, I was basically writing what you were saying. One remark which I think will be good for everyone. You mentioned about CIA. There are three vectors which you are following here. In total, IEC 62443, which is like the cybersecurity norm for critical infrastructures, they target 7 vectors. And these 7 vectors are also fulfilling functional safety too. So I think that would be beneficial if we follow those 7 vectors. CIA is included in that, which provide us far bigger coverage than just CIA.
I fully agree with you. Also, that just to mention on top, ISO 21444 also points towards such vectors. For example, one is stride, and that there are like seven of them. Like I said, I didn't want to go to in the detail of this standard. I totally agree with you. 3 is the mere basic. That is the classic IT security that we know for years. However, you need more. Definitely need more. Good point.
So that was all from my side. And anyway, thanks a lot basically for putting this together, because with this corona, everything was shut down. So
yeah, I mean, this is bringing the world together, I think. Thank you so much, Puneet. Michelle, do we have any other questions?
Ram Kumar here, and I'm currently working as an eSpice automotive spice consultant, providing consulting services for a lot of customers, OEMs, and tier ones. So the question that I have is, you talked about the concept of cybersecurity goal and item definition. Now, in your opinion, do you think the cybersecurity goal should be at the high level, or it should be more focused on the components? Depending on the components that we have, we need to define it at the individual level. And what is your take on that?
Very good question. It depends how you define a goal and a requirement. The way goal and requirements are defined in this standard, and also as you work with ASPICE and functional safety, as you know, the goals are more at the item level. Vehicle level safety goal, vehicle level security requirement. And when it trickles down to the component, we call them requirements. So this is how the vocabulary is. I think it's a wording question. The way you'd want to define the words, you should be consistent to that. I would agree with the vocabulary the industry is using. The goals should be at the vehicle level, at the item level, and we trickle our requirements down to component, software component, hardware level. This is how we do.
I think the point that you're trying to make here is the goal is then decomposed at the requirements level, and then we track it and close it. That is what is your point, right?
Yes, absolutely. Yeah, you as an ASPICE assessor, you know, we will have to have a nice traceability, and this traceability should go back to your goal.
Sure, absolutely. Okay. And one more follow-up question that you talked about when you discussed on the harmonization of the processes, right? So you were, I was not clear on that point, but you said that if you have your processes comply to functional safety, the ISO 26262 and the ASPICE, incorporating cybersecurity standard processes and also the practices would be easy. That is what you were trying to make out. Your point was on that point, right?
That'll be easier. That'll be easier. I don't want to say it's easy, but that'll be easier. I said that because my practical experience suggests me people are worried about a new standard, and they tell us to do a gap analysis on the basis of the new standard, and we discover gaps in their ASPICE process. That is the reality. And if you have a gap in your ASPICE process, how do you think you will put something on top? That was the point.
No, absolutely. ASPICE is the base processes for sure. Even if you wanted to achieve compliance for ISO 26262, you need to have the base processes, which is ASPICE compliant for sure.
Fascinating.
Anyway, I agree to your point. But thanks for that, Hasan. It was great. Looking forward to your next session on the cybersecurity validation, the right side of the wheel, right? Where I'm more interested to see what are the validation techniques we use, where we talk about the penetration testing and other areas. So looking forward for that. And this was a great session for sure. Thank you so much for that. Yeah.
Thank you, Ramkumar. And good that you mentioned about penetration testing. A little bit of insider info that we will be also putting in a series of trainings. Another training that we'll be launching pretty soon after ISO 21444 training, online training, will be on penetration testing.
Got you. Okay. Looking forward for that.
Awesome. Thank you, Ramkumar. So it was a fascinating session. Thank you, all of you. Thanks to all of you for joining. And stay healthy, stay with us, follow our podcast, If you have feedback, write me an email, or my colleague Michael and Alex will be there to help you. Yeah, it was an interesting discussion today. Thank you, everyone.